Thank you for clicking on this demo of the H2O Document Signature app. If you've ever uploaded documents to a website, you will know it's an annoying process. Sometimes the size isn't right. Sometimes you don't sign correctly, it gets rejected. From the perspective of solving this problem, it's quite a tough problem because you need to match the signature. You need to make sure it can be read by the machine. You need to make sure it's not blurry enough. And as you can see, it gets really complicated really fast. That's why, fortunately for us, I did make an app. Grandmaster Shivam, who's one of the 25 Kaggle Grandmasters at H2O, solved this problem by making an AI app for us. Shivam is a triple Kaggle Grandmaster, soon to be a quadruple Grandmaster, I believe. And he has created a stack built on top of Hydrogen Torch, which is our no-code deep learning solution, connected with Wave and MLOps to help serve this app in the App Store. With that, Shivam, could you please enlighten us on why did you decide to solve this problem and why is it a hard problem?
Yeah, sure. Thanks, Sanyam, for the introduction. So at H2, I have been working with multiple customers, and a lot of them are banks. And in banks, we always face this problem that we want to analyze a lot of documents, and analyzing documents, it's a completely manual process. So there is a big need of really understand these documents with the use of AI, with the use of state-of-the-art deep learning, machine learning models, and solve the cases where we can, let's say, detect the stamps, we can detect the signatures, we can detect the logos. And in many cases, there may be various anomalies. The signatures may not match with the other documents. Talk about a KYC use case a bank wants to do, and a customer is uploading hundreds of documents, and all of them may have some variations of signature. Manually, it may be easy to just detect, but when we talk about, say, all the customers of the bank, it becomes a big problem. That's why if we really need an AI model, which can at least guide the banking people or the bank infrastructure to give idea about this project, this person may be suspicious, these documents may not be good, and how it can be achieved by using deep learning. And that's where, fortunately, in our company, H2O, like the team of Kaggle Grandmasters have been always working on these challenging problems. And the one of the best part which I like about this team is that we try to productionize, we try to convert these use cases into products. That's what our team has been doing internally. We built this product called Hydrogen Torch. So Hydrogen Torch is a platform which can train deep learning models on different unstructured data sets. Documents may be one of them. As I mentioned, can really work on any type of unstructured data. It may be videos, it may be audio, it may be images, and in our case, it may be documents. The use case that we'll be showcasing today will be a document use case. And recently, we are also experimenting on audio use cases. And what we are trying to automate here is all the best practices in deep learning, all the state-of-the-art tips and tricks that we use on Kaggle, that people have used on Kaggle in data science, and to really automate the life cycle of a deep learning project or a deep learning model. But the journey doesn't end there. Once we have a model, once we have deep learning model built, we always need to deploy it somewhere. We always need to manage it somewhere. That's where we have this product called H2O MLOps. And H2O MLOps is a place where we can do various forms of deployments. Like here in this MLOps screen, I have deployed a bunch of models. One is a metric learning model, one is an object detection model, one is a tailored sign detection model. And then we can also take a look at, they have been deployed to different places, dev or staging servers. There have been no alerts so far, but what if my models start decaying? So I will get alerts and so on. So using all these Hydrogen Torch, MLOps, and one of the other product that we have called Wave, we developed this use case called Document Signature Checker, which essentially consumes in documents as input. And behind the scene, as I described, there is an AI engine which is used to train a model to understand documents, specifically signatures for now, but we also are working on stamp detection and logo detection. We train different models in Hydrogen Torch, we deploy them on MLOps, and using this product called H2O Wave, we generate the prediction. So let's take a look at this application in particular. So let's take a look at one of the project where we can see that there have been different type of documents have been uploaded. Some may be legal documents, policy document, policy agreement. We can take a look at the preview of this document. Looks like some document with a signature on the bottom. One thing I would like to just mention here, all of these are sample documents, dummy document. There is no customer data, no real data is being shown here. So in this video, we are just showcasing the sample dummy documents for the sake of the demo only. Right, so we have these documents. What we can do with these documents, we can run our signature detection model that we have already trained in Hydrogen Torch and already deployed on MLOps. And we can then pass on the documents that we want to understand in order to detect the signatures. And here we see that our model has detected some bounding boxes. We see that there are two bounding boxes that because of the confidence threshold that we give. Users can always tweak in these confidence thresholds so that they can get accurate bounding boxes or accurate signatures from the documents. Like in this case, we only get one because the threshold was between the minimum and the maximum threshold that we defined. Similar to this document now, the model has already computed the results for all the documents here. And we see that very quickly, model has given us the predictions. And now as a user, we can really focus on the signature part, or the area of interest part, where we or a bank are interested in asset. So this is the result of an object detection model that was trained in Hydrogen Torch. But there can be other use cases, for example, signature verification. So in case of signature verification, the use case is we want to match the detected signature against the historical signatures that, let's say, users might have added in the bank. So in this case, what a model is doing is it's matching this input image or the detected image from object detection with one of the previous historical signature that was provided in the bank, and it is calculating the similarity score. And wheresoever the score is below the threshold, it says the label is matched or not matched. So if you look at some other examples, we see that these are not matched. So probably these are major variations of someone making forgery or someone making alteration. But in some cases, we also see some high confidence, and that's because the model has predicted these are matched signatures. So in general, the use case around these models or these signature verification detection is to really automate the life cycle, or that goes through cases like document analysis, KYC, identifying forgeries in the documents, and so on. And all of this is powered through the models that were built in Hydrogen Torch, as I described. And very specifically, the model that we developed was the object detection model that detects signatures first. And the second model was metric learning model that was learning whether two images are similar or not. If they are not similar, the similarity score will be low. If they are similar, then in that case, it will be higher. So this is like
Shivam,
yeah.
So Shivam, the app connects to Hydrogen Torch, which has, like you said, all of these best practices of deep learning built in, because object detection and metric learning are also challenging problems. So you have the best practices that help solve both of these individual parts of the process.
Yeah, that's where I would like to go through the Hydrogen Torch, what exactly Hydrogen Torch tries to do. So if you look at Hydrogen Torch application, it already has ready to use templates or problem types for different types of problems, say audio classification, image metric learning, the one that I used in signature verification, object detection, semantic segmentation. So Hydrogen Torch has already inbuilt functionalities and inbuilt recipes specific to problem types. For instance, the moment I selected object detection, it showcases that there are 3 pre-trained model architectures that can be used for this task. One is faster RCNN, FCOS, and efficient det. And then we also expose a lot of hyperparameters, a lot of options for users to tweak in. But we also give a very a default value for all these models so that they can be run more efficiently. For instance, batch size is defaulted to 16, epochs are defaulted to 5, metric is pre-computed, the GPU settings have been computed, and so on. So Hydrogen Torch already has these templates or problem types with all the default settings. So without even knowing a lot about intricate details of these models or experiment, we can just quickly run the experiment and it will automate the model building part for us. And the Hydrogen Torch is also tailored for different types of user personas. Let's say a heavily experienced grandmaster is trying to build a model, so they can choose the experience level to be master, and we'll see that the page is refreshed. The page is giving different type of settings, different type of parameters like augmentation, architecture settings, training settings, and so on, which were not visible with the previous persona that I was using. So this is what Hydrogen Torch does. And to answer the next question, like once we have developed the model, so let me take a look at one of the model that I was building. So once the model is developed, we will take a look at all their metrics, all the charts, the summary, visualization. But there will be an option to download the entire model, download the model scoring pipeline, or something we have called download MLOps. So once we download this MLOps, it basically downloads an object which contains the modeling pipeline or the scoring pipeline that we can deploy it in our MLOps here. So here you see that these metric learning, object detection, sign detection were deployed in this MLOps. They were exposed via an endpoint. So if I look at an endpoint, so it gives me a curl request or an endpoint that I can use. I can go on and add it in my Wave application. So for instance, I copied it from here. If I go back to my application, so one of the tab we have is called settings, where we can configure which model you want to use. So for sign detection, let's say I want to use the recent model that I just added. If there is any password, I can add it. Else, if there is no pass, I can avoid it. So now what will happen is the application also has another endpoint for a different model to choose to make predictions. Right. So that's how this Wave application is combining the power of an AI engine, Hydrogen Torch, and MLOps for model deployment.
Thanks for the clarification. I also saw there are a few upcoming features that you've slightly teased in the app. Can you speak about those? Stamp verification, I believe, and
Yeah, that's correct. So the more we talked about this app, more we showcased this app to different people, different customer, there was increased interest about identifying other objects in the documents. Signature is just one thing, but there are many cases when they want to detect stamps, and they also want to verify the stamps. And stamp detection is even a challenging problem because sometimes stamps can be really bad. The images of the stamp can be really blurry. That's where I guess we will be building more sophisticated hydrogen torch model to detect and verify stamps. Apart from stamp, we are also going to do logo detection, logo verification, similarity between the logos. And one such use case we will be doing in the end will be alteration detection in the signatures. So this use case will be about whether there is some manipulation, some alteration is being done in the signatures. And one example of that could be, let's say someone have added an extra zero in the amount of a check, and a model will be able to detect whether that extra zero is from a different ink, different pen, as compared to the rest of the part of that value. So these will be some upcoming features that will be added in this app.
Thanks for sharing that. Again, you can find the link to this in the description of this video. And thanks again, Shivam.